Lesson 13.2 is Riemann and trapezoidal sums from tables. And it says selected values of f of x are shown in the table below. What is the right Riemann sum approximation for the integral of f of x from 0 to 5 using 4 subintervals as indicated by the table? And so normally we would want to subtract 5 minus 0, since those are x values we're going to span, and then divide that by 4, but that would be 5/4, which isn't going to work. That's not what our table shows us. So we're just going to go off the table and say that here to here is one interval, and then we have 2 to 3, right? We have 0 to 2, 2 to 3, 3 to 4, and then 4 to 5. However you can show that. And so I have to think about if I'm doing a right Riemann sum or Riemann sum, however you want to say it, I want the right value. So out of these two, I want to know the f of x. So this point, 2, 13, would be the first right-hand point out of these two. And so I see that the difference here from 0 to 2 is 2. That would be the width of my rectangle. And then the height would be f of 2, which is 13. So I have a 2 times 13. Add that to my next rectangle would be a difference of 2 to 3. 3 minus 2 is a difference of 1. And then go with the right-hand height. So that'd be f of 3, which is 10. Plus, then my next point, so I had 0 to 2, 2 to 3. 3 to 4 is a difference of 1. So that's my width of the rectangle. And then I would want to go with the right-hand side, which is a height of 6, plus another difference of 1. And then the right height would be the 5. So I'm really not going to use the 17 at all, because that's the left-handed side. And then you would just multiply and add those up, which should get 11, 20, 30, 47 be my total area. Now I provided this just so you can see it. So what we've got here is the point 017. We didn't use it because we're going to go from the right-handed side. And that height was at 13. So the height of this rectangle is 13, where the width of it was 2. Maybe I should write it here. So it's a 2 by 13 rectangle. Then my next rectangle went from 2 to 3, so that's only a width of 1. And then my height was at 10. I don't know where to write this. So 1 times 10 gave me an area of 10. My next one, only again a width of 1. The next one was a width of 1. And then this was a height of 6. So that gave me an area of 6, where this was an area of 5. So that's a good visual for you, but you have to try to do it without a graph. All right, number 2 is a left Riemann sum. We're going from x values of 0 to 14 using 5 subintervals. Again, 14 minus 0 would be a difference of 14 divided by 5. It doesn't say the subintervals are equal in width, so we'll just go from the table again to say, okay, we're going to go from here to here, and then we've got from here to here, and then here to here, here to here, here to here. Okay, so we're going to do subtract, and this time, since we're doing left, we want to use the left value in each set. So again, I'm going to subtract the x's. That would be a difference of 2, and then we want to go with 19 would be the height on the left. And then the next one, 5 minus 2 would be a width of 3, and then we'll go with the left one, which is 9. Okay, the next two would be 9 minus 5 is a width of 4. We'll go with the 5 as our height. And then this one would be width of 2. We'll go with the 12. And then the last one, that's a width of 3. And then we'll go with 18. So this time we're not using the very right number. Go ahead and figure out what that is. And I got 163 for that, and then I drew this out. Ignore this line right here. I accidentally did a right hand first instead of left hand. So each left point is what we're making our rectangle go up to. So you can see where this had a width of 2, a height of the 19. And then the next one had the height of 9. The next one the height of 5, 12, 18. So hopefully that gives you a good visual. Okay, and then number 3. Same thing, but this time it's a midpoint Riemann sum. So a midpoint has to literally be in the middle. We can't use either end point of that interval. From 2 to 14, using 4 subintervals. And so I like this, that it tells you at 3.5 that is in the middle, and 6.5 is in the middle, and 9.5 is in the middle, and 12.5 is in the middle. Because you could average these and say, okay, well, this is 25, half of 25 is that, half of 19 is 9.5. And so my intervals, excuse me, it's here to here, here to here, here to here, and here to here. That would be my 4 sub-intervals. So same thing, I've got to subtract the 5 minus 2 would be a width of 3, but then I'm going to use the height at the middle. So the 6.5 is the only number I want. I don't care about these. Plus the next interval would be 8 minus 5, which is another width of 3, and I'm going to use the height at the midpoint. And then the next interval, 11 minus 8, is another width of 3. Hey, they're all equal. And then use the middle height. And then the next one, 14 minus 11 is 3. And then I'm going to say the middle height is 16. And I got 117 for that. So what's happening here is we went from 2 to 5, here to here, where the middle was here at 3.5. So our box is going to be flat like that. And so we found this had a width of 3. And then our height was whatever the height of that middle point was, which was the 6.5. So that happens every single time. It's the midpoint height that we want. So hopefully you get the gist of that. One more example to do. Number 4 says we want to find a trapezoidal sum. So first let's talk about a trapezoid. It has one set of parallel bases. It has some kind of height which has to be perpendicular, and the formula for the area is 1/2 times the sum of the bases times the height. So there's several different ways that you could do this. Let's look at how many intervals we need. We're doing 4, so this will be 1, 2, 3, 4. It's easier for me to draw an arc like that than how big I was doing on the first ones. Okay, so from here, I want to figure out, or I know, I guess I'll say that I'm always taking times 1/2. And so for me, it makes more sense to just take the whole sums times 1/2. And then also the heights are going to be the widths, because they are going to make a 90 here. So my trapezoids that I'm making are called right trapezoids, where they have a right angle here. And so if I could just do that, that'll tell me what I need to multiply by. And it looks like it's not a common, right? That'll be with a 4, 2, 1, 11. So I'll have to change those each time. So then let's do a bracket. And then I'm going to add my 2 bases together. And my bases are going to be my heights. This would be base 1, whereas this would be base 2. So I would have 0 plus 4, and then times the height of it, or the width, which was my 4. Oh, I didn't mean to do 0 plus 4. I meant to do 14 plus 18. 14 plus 18 divided by 4. No, times 4. Holy cow. I'm getting it mixed up with the other way where you could divide by 2. So times 4, sorry. You could, instead of having 1/2 out the whole way, you could have 14 plus 18 divided by 2, because that's averaging. That's the same thing as multiplying by 1/2. So you could do that as well. I'm trying to figure out which is the easiest for you to follow. So there's one trapezoid area, right? We've got height is 4. Our bases are, this is a distance of 18. Oh my gosh, 14 and 18. Okay, and then the next one would be height of 2, because 6 minus 4, times, then the bases would be 20 plus 18, plus the next one would be a height of 1, 7 minus 6, and then add 20 plus 21. And then the last one would be 4 for the height, and then add 21 plus 41. And so you won't do the 1/2 until the very end with the way I did it. But again, if you would have wanted to have all of these just divided by 2, then times your height, that would have worked fine, and then don't do the 1/2 either way. And I got my final answer to be 246.5. So I didn't do the divide by 2, I just got my 14 plus 18 times 4 to be 128. My next number would be 76, 41, 248. That added up to make 493, and half of that is 246.5.